Right. Okay, right. Write down the topic today. Write down the topic as binomial theorem. Ane? Binomial theorem. Binomial theorem. Ane? Binomial theorem. Right.
This one is it's E, right?
Right, binomial theorem. Binomial theorem. Okay, right, binomial theorem. Right. Now, now, but in these days, you will get only 25 mark question, okay? Not an essay question, but essay questions has been also asked, okay? But nowadays, you only get 25 marks for this one. But it can be an essay question as well for you, okay? So, first of all, write down after this, write down this subtopic. NCR mean one factorial and over factorial r, then n minus r factorial. As an example, imagine you need to find the value of this one 5c3 lemma. Okay, we are going to find the value of 5c3 lemma. So 5c3 means factorial 5 lemma. Factorial 3 lemma. 5 minus 3 lemma, that is 2, ne? So that is factorial 2 lemma. Can you remember factorial 5 lemma? Factorial 5 means 1 into 2 into 3 into 4 into 5 lemma. Factorial 3, 1 into 2 into 3. Now we have discussed this in what? The derivatives, right? Right. And factorial 2 mean again 1 into 2 lemma. You can now simplify this expression. You can cancel out 1, 2, 3, 1, 2, 3 just like that. 4 into 5 mean 20, 20 by 2 mean that is equal to 10. Okay. So just like that we can simplify the NCR notation and we can find the relevant value here. Okay. Now there's an easy method to find the NCR value. You have to remember this one as well today. Again, imagine you need to find 5c3 lemma. Right? The shortcut method is lemma. You need to multiply 3 times lemma starting from this 5 lemma. Just like this 5 into 4 into 3 lemma. Okay, look how many numbers 1, 2 and 3 lemma. Then you need to divide this by what? Factorial 3. Factorial 3 means 1 into 2 into 3 lemma. Okay, you can see you can get the answer very easily. Oh, what happened? 2 and 3 you can see. So 3 and 3 is this 2 lemma. 2 into 5 that is equal to 10 lemma. Right? So that is the easy way, the shortcut method. Starting from 5 lemma, multiplied up to what? 3 lemma. Okay, then divided by what again? Factorial 3. Again, you can get the answer just like that. Okay, so I have to remember the definition here. So this is the way to find the 5c3 using the definition. But normally when we solve the questions, we are not going to use this method. Instead of that, we are going to use this shortcut method. Okay, 5 into 3 multiplied 5 into 3 lemma, then divided by factorial 3 lemma. So that is the shortcut method. Okay, let's write down this first lemma and we can continue. Okay, fine. So write down this one today. Definition of NCR. Okay? Definition of NCR notation. Then definition of NCR notation. Then write down this one and highlight this one. NCR factorial in over factorial r in minus r factorial. There's a condition also, you have to write down this condition as well. So this is the condition today. Condition is here. N can be 0, or we can say that n is a non-negative number. I'm going to put a star and write down that n is non-negative number or non-negative integer. Non-negative integer. So non-negative integer mean what? Non-negative integer. That means it can be 0 or it can be positive value. It can't take a negative integer today, but it can be 0 as well today. Okay? Right. And there's another condition today. Here this r lamai that is greater than or equal 0 lamai, but less than or equal n lamai. So here you can again see lamai. R is again what? Some kind of a positive integer lamai. It can be 0 or it can be a it should be less than n. Okay? You can't take every value for this r lamai. It should be less than equal n but greater than equal 0. So that means today always this r is what today less than this n. So what is the maximum value this r can take lamai? N. It can't exceed the n value. Okay? So this is the maximum value this r can take, that will be n. Now that means today now this is impossible lamai. There can't be this kind of things lamai. 5c7 today. That's not possible because this is 5 lamai, this is 7, this can't be 2 lamai. Right? So always lamai, this r number is less than or equal to this n lamai. Okay, but what is the least value r can take? 0. That means, is this possible lamai, this kind of thing? No, that is not true again. Okay, right. So these are the two things today you need to remember. These are the two conditions of NCR notation. Right? Remember this one. Right? Let's write down some examples today. Right, write down the first example today. Example number 1. 5c3. 5c3. Let's write down this first method lamai using the definition. So 5c3 means for the factorial 5 over factorial 3 factorial 2 lamai. It's factorial 5 mean 1 to 5 lamai. Then factorial 3 mean 1 into 3 lamai, 1 into 2. Can cancel out these terms. My answer will be 10. Right. O, you can write down the shortcut method for the O. Then O again. 5c3 is equal lamai. You need to multiply starting from 5 lamai up to what? 3 lamai. So that means 5 into 4 into 3. Just like that. Then divided by factorial 3. So again the answer will be equal to 10 lamai. Okay. Right. Number 2 lamai, try to find the answer for this one today. 10c2. I think if you use the shortcut method, that will be easy lamai. Use the shortcut method for 10c2 lamai. Use the shortcut method. 10c2. 10c2. So that is very hard. I just forget that. 10c8 is more than beta cover. Doesn't matter. So multiply starting from 10 to 2 lamai, then divided by factorial 2. Sorry about that. They were not feeling well, but so 10c2 means 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 lamai. Then divided by factorial 2 means 1 into 2. So you can cancel these 2. So what is the answer, lamai? No, that is wrong, lamai. Sorry. 10 into 2 only. Only 2 times you need to do the multiplication. Here you need to do 3 times, lamai. Not up to 3 lamai. Here lamai 5c3 means 5 into 4 into 3. That's it. What is only 3 times. So here lamai you need to only multiply, do the multiplication 2 times. That means 10 into 9 lamai. That's it. So it will be 5. 5 into 9 for that will be 45. Only that means only 3 times, only 2 times. 10 into 9 over factorial 2 now. So that means how many times you will do the multiplication? Huh? Right. Number 3 lamai. 6, let's say 3 lamai. 6c3 lamai. So 6 into 5 into what for they? 6 into 5 into 4 over factorial 3 mean 1 into 2 into 3 lamai. So it will be equal to lamai 20 lamai. Ne? That's it. 20 ne? Okay, right. So just like that today we can find the value of this given NCR value lamai. Okay, right. Now let's go forward lamai. Right. Then we write down the properties of NCR notation. 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 Properties of NCR notation. Okay, right. So this is the first property bude. And okay, this is the first property bude. NC0 is equal to 1. Also lamai, NCN is also equal to 1 lamai. So this is the first property bude. Let's see the proof later lamai. First of all, let's write down this one and let's highlight that one today. So you have to remember this one. This is the first property lamai, property number 1. NC0 is equal 1. NCN is equal 1. Right. Now tell me Pute. Now if you see something like this Pute, 5C0. Now you don't have to think about this one. What is the answer? 5C0? Just one number. Okay, fine. Next one Pute. 6C6 lamai. What is the answer? Just one. Okay, so keep in mind this lamai. Very easy. Right? 5C0, 1, 6C6 lamai again equal to 1 lamai. Okay, write down these two examples. Right. So this is the proof lamai. You can see here the proof lamai. So NC0 means for the factorial n, factorial 0, then factorial n. So that means 1 over factorial 0. What is factorial 0? Factorial 0. But, okay, 1 over 1, that is equal 1. NCN naman, factorial n, factorial 0. Then 1 over factorial 0 in 1. So that means for the NC0 is equal to NC. So just like that, we can do the proof. Write down the proof. Right, okay? Right. Theorem number 2 lamai. Okay? Write down the second property lamai. Second property. Second property. Right. So this is the second property. NC1 is equal to N lamai. Again highlight that one. NC1 is equal to N. Right. So that means lamai 5C1 as an example. So what is the answer for 5C1 lamai? Just 5 lamai. Okay. 10C1 Pute. What is the answer for 10C1? That is just 10 lamai. Okay. Right. So okay, write down these two examples today. 5C1 is equal 5. 10C1 is equal 10 lamai. So if there is one here lamai, you can see the answer is equal to the n lamai, right? So 5C1 is equal just 5. 10C1 is equal just 10 lamai, just like that. Okay, right. Just write down this proof as well today. So NC1 today, that is factorial n over n minus 1 factorial 1 today. Right? So just look at here, lamai. Factorial n mean today 1 into 2 into 3 into up to n minus 1 into n lamai. And you need to divide this by factorial n minus 1 mean today 1 into 3 into 3 into n minus 1 today. So you cancel out this one today. This will be equal to n lamai. Okay, so I will explain that later. So here Bude, can you understand this one? Factorial n or factorial n minus 1 Bude. Factorial n mean 1 to n lamai. So here you can see n minus 1 n lamai. So tell me Bude, another term Bude before n minus 1 Bude. What is the term lamai? N minus 1 n. So here lamai, what is the relevant term? N minus 2 lamai. You can see lamai, always lamai. One number is added. 1, 2, 3, just like that. So n minus 2, n minus 1, n next term should be n plus 1 today, just like that. Okay, so when you divide it by again factorial n minus 1 today, answer will be n, right? Now tell me today, just looking at this one, factorial 4 over factorial, sorry, factorial 5 over factorial 4 lamai. So what will be the answer? Yes, 5. Okay, 1 to 5, 1 to 4. So that means it will be equal to 5. Right? So keep in mind that also, right? Right, so this is the proof lamai. This is the second property of NCR notation. Okay, right. Write down the third one. Right. Now number 3. Number 3. Third one today. Third one is NCR is equal to NC n minus R. NCR is equal to NC n minus R. Another important property today of NCR, we can use it to solve questions easily. Right? Right. So NCR is equal NC n minus R. That means 10C2 is equal to what Pute? 10C8. What is number type? Another one Pute. 12C11 is equal to what Pute? 12C1. So that means that is equal to 12. Very easy. Right. 765 lamai. That is equal to 7C2 lamai. So just like that today, we can apply this NCR notation. Okay. Let's write down these 3 examples today. So 10C2 is equal to 10C8 lamai. 12C11 is equal to 12C1. 7C5 is equal to 7C2. Right? Just subtract these two lamai. 7 minus 5, 12 minus 7, 10 minus 2. Just like that. Let's prove this also. We have to prove kaladamo. Okay. So this is the proof lamai. I will do the proof here. Now prove this thing today. I'm going to use the NCR n minus R. I'm going to write down the definition here. So what is the definition? Factorial n over n minus R factorial. What is the next term? N minus n plus R. That means it will be factorial. When you take the difference here, n and n will cancel out. It will be factorial R. Just like that. Okay. Again, I'm going to rearrange these terms. Then you can see something like this. Right. So when you see this thing, can you remember what is this thing? Factorial n over factorial R, n minus R factorial. That is NCR. Okay. So that is the NCR. So just like that, we can prove that NC n minus R is equal to what? NCR. Okay. Write down the proof now. It's very simple proof. Just write down the definition of NC n minus R. Do the simplification. Then you will see that it will be equal to NCR. So that is the fourth property of NCR notation. This is the fourth property. Right, next one. Right, number 4. Right, fourth one. This is the fourth one. NCR plus NCR minus 1. That is equal to n plus 1 CR. But this is not that important because from this theorem, this property, no questions has ever asked. So this is not that important. Just write out that NCR plus NCR minus 1 is equal to n plus 1 CR. Right. That means, if you want to use this theorem, definitely they will ask you to prove this one first. It's a proof then they will ask the question. But never wanted to apply this theorem for any question of binomial theorem. Okay. As an example, you can see here 5C4 and 5C3. So this is equal to what? 6C4. So just like that, we can apply this theorem. But let's write down one more example. Next, after that, we are going to prove this one. Okay, I write down this example. 5C4 plus 5C3, that is equal 6C4. Right? Okay, let's prove this one. So this is the proof. So this is the proof. So I'm going to use NCR plus NCR minus 1 right? So I'm going to use the definition here. My NCR means factorial n, factorial r, n minus r, factorial. Again, factorial n minus r plus 1 factorial, then r minus 1 factorial. Right. So I'm going to take out the common terms. You can see factorial n is common. So 1 over factorial r, n minus r factorial. 1 over n minus r plus 1 factorial, r minus 1 factorial. Okay. Now I need to take a common denominator here. Okay, right. So to take the common denominator, I'm going to think about this factorial r and factorial r minus 1. Okay. So when you look at these two numbers for these two factorials, tell me what is the bigger one, factorial r or factorial r minus 1? Factorial r is the bigger one. R minus 1 means less than 1. So it is smaller. Okay. Now, if I want to make this into factorial r, what can you do? Before that, tell me about this one. Factorial 4, I'm going to multiply it by 5. So what is the answer? It will be factorial 5. When you multiply factorial 4 with the next number, factorial, that means 5 that is equal to factorial 5. Okay. So I'm going to use that theorem here. You can see here r minus 1 factorial, I need to make that into factorial r. So that means I need to multiply this by what? R. Got it? So if I multiply this by r, this will become factorial r. Okay? So that means if there's factorial r, I can create here factorial r by what? I'm going to multiply both denominator and numerator by what? Simple r multiply. Okay, right. Next one is consider these two, n minus r plus 1. What is the greater one? Again, you can clearly see n minus r plus 1 is the greater one. Okay. Again, I need to create a common denominator. I am going to recreate n minus r plus 1 over here lamai. To do that, Pute, what should I do? Again, the same thing. I need to multiply this denominator and numerator by what, Pute? N minus r plus 1. That is the next term. Okay. N minus r was the next term. N minus r plus 1. Okay, right. So here lamai 1 over factorial r n minus r factorial, Pute. I'm going to multiply both denominator and numerator by, Pute, n minus r plus 1. Again, Pute, n minus r plus 1, just like that. Okay, fine. Here, Pute, 1 over n minus r plus 1 factorial and r minus 1 factorial lamai. Here I'm going to multiply this by r and r lamai, just like that. Okay, right. So LHS side is equal to factorial input A, right. Now here you can see, Pute, n minus r plus 1. Denominator, Pute, what will happen to the denominator? Factorial r, factorial n minus r plus 1, Pute. Factorial r n minus r plus 1 factorial. Again here lamai r over n minus r plus 1 factorial factorial r. You can see there's a common denominator. You can simplify the numerator with it. So factorial n lamai, when you add these two, it will be n plus 1 over factorial r n minus r plus 1 factorial. Now again tell me about this. Factorial n is multiplied by n plus 1. That will be equal to n plus 1 factorial. So that is equal n plus 1 factorial over factorial r n minus r plus 1 factorial. So if you look at this very closely, you can see that this is equal to what, today? N plus 1 CR. Factorial n plus 1 factorial r n plus 1 minus r. You can see that. Okay, so that is equal to the, yes, we can write down the answer. So just like that, we can do the proof. But this is not that important. Okay? This one is multiplied by this one. Here minus r and positive r will cancel. right? Okay. And the last one today, but this one is important today. In 2000, I think 16 or something like that. Right? They asked this theorem. Right? So this is the last property of NCR notation today. Okay? So number 5, ne? Write down the number 5. The fifth one. Right. So right. So this is the last property of NCR notation. Okay. This one is for the NCR over NCR minus 1. This is equal to my N minus R plus 1 over R. Okay. Now we have to be very careful when you're using this one today. Now, where is this R here? You can see R is here and R is here. Right? So here, when you apply this theorem, you the property today, this R mean today this one, only this one. Okay, so that means N minus R plus 1 over again today this R. As an example today, imagine this one today 5C4 over 5C3 lamai. So what is the answer for this one today? You only have to worry about this 4 lamai. May I get it? Okay. So what is the answer lamai? 5 minus 4 plus 1 over lamai again 4. Okay. So that means 6 minus 2, that will be 2 lamai, 2 by 4, that is equal to half. So just like that, we can apply this theorem. But keep in mind that today, this is the only R today that involved into the answer. So N minus R plus 1 over again R. Okay. Right. Okay, write down this one today. Again, highlight this R. R highlight color. That is the only R we want to consider here. Okay. So N minus R plus 1 over again R. Write down this example as well, but we need to prove this one as well. Let's prove this. You can see this is the column we are talking about. Okay? This goes to the denominator and goes to the numerator. Same 4. Right. Now let's prove this one today. Okay? So I'm going to prove the theorem now. Right? So this is the proof of this last property of NCR notation today, right? So NCR over NCR minus 1 today. NCR means today factorial n factorial R n minus R factorial over factorial n lamai R minus 1 factorial n minus R plus 1 factorial. Then cancel out these two, factorial n and factorial n lamai. So this will be equal to my R minus 1 factorial n minus R plus 1 factorial over factorial R n minus R factorial. Let's do the simplification now, Bude. Now, Bude, if you consider these two, tell me what is the bigger number? R minus 1 factorial and R factorial? R lamai. So when you do the simplification, Bude, the denominator, there will be what lamai? R lamai. Okay. When you consider these two lamai, what is the bigger number? N minus R plus 1. So in the numerator lamai, there will be N minus R plus 1. So just like that, we can do the proof. Okay. Write down the proof lamai. Okay, right. Now we can start the binomial theorem result. Now we have discussed about the NCR notation. Right? So we need that basic knowledge. Now we can start the binomial theorem result. Okay, right. Now to start the binomial theorem, we need to start from the Pascal triangle. Can you remember the Pascal triangle? Pascal triangle. In early days, we have discussed about the Pascal triangle. The Pascal triangle means one. There's again one and one. So you can write down the sum of this one and one over here. It will be two. Again one and one. So here lamai three. This is three lamai. Again one and one. So it will be 4, 6, again 4, 1 and 1. So can you tell me what are these numbers? What are the numbers again? They are the coefficients neither. Right? Now you can see lamai. This is the power 0. Power 0 lamai. Okay. So here lamai, the power 1. These are the coefficients. This is power 2. Power 2 mean now if you expand x plus y whole squared x is squared 2xy plus y squared. So 1, 2 and 1. These are the relevant coefficients. So just like that this is what power 3 lamai. And this will be power 4 lamai. So these are the coefficients. If you consider x plus y to the power of 0 lamai, it will be just 1 lamai. X plus y to the power of 1 lamai, what are the expression? Just x plus y. So what are the coefficients? 1 and 1. Right? So just like that these are the coefficients. Okay, right? Now, when we look at the coefficients, we can see something like this. Who has seen this one? Newton. Newton has seen this thing. When Newton we can write down these numbers using the NCR notation. Newton right? When you look at this Pascal triangle, Newton saw that we can write down these coefficients using the NCR notation. So one mean what? If the power is 0, we can write down this as 0 C0. That is just 1. Okay, right? So if you consider these two lamai, this is 1C0 and this is 1C1 lamai. Both are equal to 1. Okay, right? Next one is this one 2C0, 2C1, 2C2. Now we know that 2C0 mean 1. 2C2 lamai 1. 2C1, that is just 2. Okay, right? Here lamai 3C0, 3C1, 3C2, 3C3 lamai. Again, you can see both are equal to 1. 3C1 means 3 lamai. What about 3C2 lamai? 3C2 again equal to 3C1. Okay, so that means again that is equal to 3. Okay. If you go to the here lamai 4C0, 4C1, 4C2, 4C3 lamai, and finally 4C4 lamai. Okay. Now Newton saw this thing lamai, saw this pattern. Okay. Now Newton decided that we don't need Pascal anymore. Okay. We can write down the coefficient of any power lamai without using the Pascal triangle. Right? Now we can do this today. Now tell me lamai, if the power is 5, lamai, what are the relevant coefficients today? Balannako power 3 unanan 3C0, 3C1, 3C2, 3C3 lamai. Power 4 4C0, 4C1, 4C2, 4C3, 4C4 lamai. So just like that today, if the power is 5 lamai, what are the relevant coefficients today? Start from 5C0 lamai, then 5C1, 5C2, 5C3, 5C4 and 5C5. We know how to determine these 5C1, 5C2, 5C3 values. That means do we need another Pascal triangle? No, we don't need that. Then power 10 what are the relevant coefficients? 10C0, 10C1 up to 10C10. These are the coefficients. So Newton saw this pattern. And then he invented the binomial theorem. So let's write down this one first. Right. Let's consider the Pascal triangle today. Let's consider the Pascal triangle. When the age was 23, Newton age 23 he invented the limits, calculus, derivatives, integration, binomial theorem, and he also found out there are 7 colors in the sunlight. When he's only 23. මේ ඔක්කොම හොයාගත්තේ මොන කාලේද? ඒගොල්ලන්ගෙත් අර කොරෝනා වගේ අර මොකක්ද ආව කිව්වනේ මොකක් හරි සීන් එකක්. එතකොට මාස 3ක්ද මාස 6ක්ද ගෙදර හිටලා කියලා කිව්වනේ කැම්පස් එකේ ලියනවලු. in that year. එතන මේ ඔක්කොම ගෙදර ඉන්න ගමන් නිකම්ම තමයි. gravity ඔක්කොම හොයාගත්තේ ඔක්කොම ඒ කාලේ. ගෙදර ඉන්න ගමන් සෝෂල් මීඩියා මොකුත් නෑ කරන්න දෙයක් නෑ නේද? Right, so write down this Pascal triangle, Pute. Write down the power zero, then Pute, write down these the coefficients and the relevant NCR value here, like, close to these numbers. Okay? And you can also see the pattern. That's the pattern of payment. Pascal තමලා හිතවත් දන්නේ නැහැ. Write down the power as well. The power 0, power 1, power 2, power 3, power 4. That is the power of the expansion. 0th power, the first power, second power. Right, okay, right. Now the thing is, now without using the Pascal triangle, now we can say what are the powers, what are the coefficients of the fifth power of a binomial expansion. Without using the Pascal triangle, we can tell these things. So let's write down this one for you. Right. Now without using the Pascal triangle, 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 we can write down the coefficients. We can write down the coefficients. We can write down the coefficients of a fifth power binomial. Of a fifth power binomial. Of a fifth power binomial. Binomial means there's only two terms. fifth power binomial. Okay. So what are the coefficients? Pute? You can write down these things. Lamai 5c0, 5c1, 5c2 up to 5c5. So just like that, Pute, if the power is 5, we can write down relevant coefficients. If the power is 6, Lamai, we can write down the coefficients. Pute. Right. Right. Okay. Then they write down this subtopic. Okay. Write down this subtopic. General definition of a binomial expansion. General definition of a binomial. General definition of a binomial expansion. General definition of a binomial expansion. General definition of a binomial expansion. Right. So this is the thing Newton said to us today. So this is the Newton's binomial expansion. Okay, fine. So Newton says something like this today. Now imagine the mind, you need to find the expansion of x plus y to the power of n llama. So it can be 1, 2, 3, 4, anything llama. Okay, fine. So like this today, we can write down the coefficients for this, starting from nc what? 0 llama. Then I'm going to write down this x here. X is the first term llama. Then the power of x llama is equal to the difference of these two numbers. That means n minus 0. That will be n llama. And the power of the next number is equal to the power of here llama, 0. What is the power 0 mean? But just 1. So I'm going to not write. No, I'm not going to write down that here. Okay. Next one in C1. Can you tell me what is the power of x llama? N minus 1. What is the power of y llama? Just 1. That means just y llama. Okay. In C2 llama, x in minus 2. Then put a y square. Then I'm going to write down some terms. Then I'm going to write down the general term here. If we take the general term as the R, and we can do that later in the series lesson, but normally general term is denoted by the symbol R letter. So NCR, what is the power of x? N minus R. What is the power of y? R. Then again, put some dots, and I'm going to write down the last term. NCN, what is the power of x? 0. So I'm not going to write down that. Y to the power n llama. So this is the binomial expansion. Okay. So using that one, we can expand anything. We can just expand anything llama without using the Pascal family. Okay. Let's write down this one. Then let's highlight this one. Okay. Right. So write down x plus y. Let's consider the expansion of. Let's consider the expansion of. Let's consider the expansion of x plus y to the power of n. X plus y to the power of n. Right, then they write down this expansion. Now this is the general term. This is the general term. So this is the general term. Right, right. Only this one is. Write down the expansion. That is wrong. What are you? Yes. So just write down. This is the expansion. And this is the general term. This is the expansion. Okay, Lamai? Right. Now let's take an example and see, Lamai, how can we do this, Lamai? Alright, let's take some kind of example today, right? Right. So look at this one today. Look at this example very carefully today. Right. So I'm going to expand this one today. X plus 2 to the power of 5, Lamai. I'm going to write down the expansion here, Lamai. The power can put a list. X plus 2 to the power of 4, Lamai. Okay. So here is the expansion, Lamai. 4C0, Lamai. Tell me what is the power of X, Lamai? That is 4, Lamai. Okay. Next one is for the 4C1. What is the power of X, Lamai? X cube. What is the power of 2, Lamai? Just 1. Okay, right. Next one for the 4C2. Then X squared. What is the power of 2, Lamai? 2 squared. Then for the 4C3. What is the power of X? 1. 2 cube, Lamai. And finally for the 4C4. X is cancelled. X is vanished. It's power 0 and it will be 1. Here put 2 to the power 4, Lamai. Okay, right. Now I'm going to remove this NCR notation today. 4C0 mean what today? Just 1. So x to the power of 4. 4C1, 4. 4 into 2, 8. So 8 x cube, Lama. 4C2, 4 into 3, 12. 12 by 2, 6, Lama. 6 into 4, 24. So 24 x squared. 4C3 is equal to 4C1, that is 4, Lama. 4 into 8, that means 32 into x, Lamai. Finally, 4C4 means 4C1, that is equal to 1. That means 2 to the power 4 means 16. So just like that today, we can write down the expansion of x plus 2 to the power 4. Tackle. Right. How good was Newton? Right, finished. Right. Right. Now the next thing is Lamai. When if there's a negative number, Lamai, right? May just look at this one. Again, look at this one. Now I'm going to expand today this one. Imagine 2x minus 1 to the power of 4, Lamai. I'm going to expand this expansion number. Okay, right? So keep in mind that if there's a negative number, we can convert or we can rewrite it in this form, positive minus 1. Now, when you train this one, you don't have to write down this step, Lama. You can just write down the expansion. So, but now, Lama, if there's a negative number, I'm going to write down 2x positive 1, then minus 1 to the power 4. Lama. Okay. Now, we can apply the binomial theorem again, Lama. So, 4C0, Lama. 2x to the power of what, Lama? 4. Right. Next one, 4C1, 2x cube, Lama. Then, minus 1 to the power of 1, Lama. Okay. 4C2, 2x squared lamai minus 1 bude square 4c3 2x to the power of 1 minus 1 cube lamai finally 4c4 lamai minus 1 to the power of 4 lamai. Okay, so just like that we can do the expansion. So here lamai it will be 1 2 to the power of 4 mean bude 16 x to the power of 4 lamai. Here, Lamai, be careful here. This is 4 Lamai, this is 8, and this is negative. That means minus 32 into x cube Lamai. Okay, right. Next one is 4C2. That means what? 6, 6 into 4 Lamai. That means 24 x squared positive. 4C3 means 4 Lamai. 4 into 2, 8, but minus 8 x Lamai. Finally, Okay, right? Okay. Now after that, today, take the tutor and do the right. Okay. Now after that, today, take the tutor and do these expansions. Okay. Try to do question number E and F lamai. E and F and B lamai. B, E, F. Okay. Try to write down these three expressions. They B, E, and F lamai. So just tell me if there's any difficult one. Yo, that is the problem. Say any power bank and may do only these two only put the B and E, that is enough. Okay? Don't do the F lamai, only do B and E, two questions. So first one is done. Next color. So the B, ne? B is x minus 3 to the power of 5. Right. Finished. Okay. B and E, that is enough. Now you can check the answer with your friend. Both are equal to. So is there any hard one? Right. So this should be the answer for the question number B. Ne? X minus 3 to the power of 5. Now tell me, what is the code? What is the answer? Nama? X minus 3 to the power of 5. Nama? Write down the answer. Right. So it should be x to the power of 5 minus 15 x to the power of 4, 90 x cubed, 270 x squared, 405 into x minus 243. Now. You can check the answer. This one. And put 1 plus 2x to the power of 4. Now. 1, 8x, 24x squared, I think 32x cubed. Ne? And finally 16 x to the power of 4. 32x cubed. Ne? Only 32 has it. Right? Okay. Okay, but right. Okay. Now the next thing is Lamai. Look at the next thing Lamai. Right. Next thing is if there is 1 here, and that means 1 plus x Lamai to the power of n Lamai. Okay, so if you get this kind of expansion today, that is easy. Now to expand this kind of expansion Lamai, that is easy. Reason is Lamai, you can see here, NC0 Lamai, 1 to the power of n Lamai. Always Lamai, any power of 1 is equal to what? 1 Lamai. So we only have to worry about what today? This second term. Got it today? So if you got this kind of expansion today, that is very easy. Mean NC1 x, NC2 x square, NC3 Lamai x cube, and it goes on like that today. NCN xn. Okay. So if we can write down an expression today in this form Lamai, binomial expansion in this form Lamai, expansion becomes easy. So that is not a compulsory thing. You can use this pattern if you want. If you look at the expansion here, if there's 1 in the beginning, expansion becomes easy. Okay, so let's write down this thing as well. Okay? If we consider the 1 plus x to the power n, this one, if we consider 1 plus x to the power of n expansion, put a comma, then put write down this one. 1 plus x to the power of n mean this one. One plus x to the power of n, I write down the expansion today just like that. Right? Then we write down this one. Expansion becomes easy. Expansion becomes easy. Expansion becomes easy. Expansion becomes easy. Right. So write down this question after that. Write down this example question after that. Okay. Right. Write down the expansion of. Rewrite the expansion. Rewrite the expansion. 3 plus 2 plus 3x to the power of 3. This one. 2 plus 3x to the power of 3. In the form 1 plus 6 to the power of n. 1 plus 6 to the power of n. Then do the expansion. Then write down the expansion. Then write down the expansion. Then write down the expansion. Right. Now let's see how can that be done. Okay, right. That is very easy. Now here you can see the original one is 2 plus 3x cube. Now how can we convert this into 1 plus x? That means here it should be 1. So I'm going to take out 2. So when you take out 2, it will come out as what? 2 cube. That means 8. Okay. So here 8 into 1 plus 3 over 2 into x cube. Got it? Now it's easy to do the expansion. 8 into 3c0, 3c1, 3x over 2. 3c2, 3x over 2 square 3c3 3x over 2 cube just like that. Okay, right. That means 8 into 3c0 means 1. 3c1 3, 9, 9x over 2. 3c2 means 3c1 again 3, 3 into 9. 27 x squared by 4. And here again it will be 1 27 x cube over 8 Finally you can multiply it by 8. So 8, 36 into x, 2 that means 54 into x squared and 27 x cube. So like that we can do the expansion. So that is not a compulsory thing. That means we can do something like this. That's it. We can do something like this if we want. The thing is, we only have to worry about the second part of this expression, because there's one. We don't have to worry about the one. Then it will become easy. You can see now. If there's 1, it will be 1 here. 2, 2. If there's 3, it will be 2. So it will be easy. So that is the expansion of 3 plus 3x cube. Okay, right. Now let's go to the first question type of this lesson. Okay, right. So there are some few question types. This is the first question type. Okay. Then they write down first question type. First question type. First question type. Then they write down this sentence of that one. First question type. Then write down this sentence. simplifications of expressions atau simplifications of binomial expressions putih expansions simplifications of binomial expansions. Nah, memang putih simplifications of binomial expressions using binomial expression. Simplifications of binomial expressions. Just write down as a sentence. Topic ekmat kawan ya. Simplifications of binomial expressions putih using binomial expansion. Simplifications of binomial expressions using binomial expansion. Right. Write down this question after that putih. Okay? Write down this question putih. Simplify x plus a to the power of 4 positive x minus a to the power of 4. Simplify x plus a to the power of 4, then x minus a to the power of 4. Right. Now there is a method to do this. Okay? So just look at here. How can we do this kind of a simplification? Okay. Right. Now when we got this kind of a question today, we only need to do the expansion of the negative expansion today. You can see negative 1 is x minus a to the power 4. So I'm going to only write down this today. Expansion of x minus a to the power 4. So what is the expansion today? 4c0 into x to the power 4. Then today 4c1 x cube. Now be careful, there's a minus a. So minus a to the power 1. 4c2 x squared, then today minus a squared. 4c3 x to the power 1 minus a cube. 4c4 finally minus a to the power 4. So just like that today we can write down the expansion. Now from this expansion today, identify what are the negative values. You can see this is positive. What about this one today? It's negative. Minus a to the power 1. So this is negative. This is positive today. This is again negative. So just like that today we can identify the negative numbers. Okay, fine. After that today I'm going to write down again x plus a to the power of 4 positive x minus a to the power of 4. These two lamai. Now today just think, if you do the expansion of x plus a to the power of 4 lamai, all the terms will be what? Positive. So here we know the expansion lamai. There are some negative numbers today. So when you add these two lamai, what will happen? These negative terms will cancel out with these positive terms. Now what about these positive terms? They will be double. So that means the answer is 2 into 4c0 x to the power 4. This term will cancel out with a. So 4c2 x is squared and again a squared. Final one with a 4c4 a to the power 4. Just like that. Okay, fine. Now we can write down the answer today. So 2 into 4c0 means just 1 x to the power 4. 4c2 means 4 into 3, 12, 12 by 2, 6. So that means 6 a squared x is squared. And here again a to the power of 4. So the answer is 2x to the power of 4, 12 a squared x squared, 2 into a to the power of 4. So just like that we can get the answer. Okay, so keep in mind that today when you got this kind of a question today, always write down the expansion of the negative one. And keep in mind that we are not going to simplify that one today. Just leave the answer just like that. Okay. Then today add these two, cancel out the negative terms lamai, double the positive values, positive terms today, then remove the NCR notation today, then you can get the answer. Okay, right. So write down the answer. So that is the first question type of binomial expansions. Right, Pute? Right. Now look at the question, Pute. $37. Question number 37, Pute. Right. Now let's try to do this question, Pute. Question number 37. Using the binomial expansion for a positive integer integer line, index, Pute, show that 1 plus root 3 to the power of 6 positive, 1 minus root 3 to the power of 6 is equal to 416, Pute. Right. Let's try to prove this thing, Lamai. I will tell you how to do the second part, Lamai. Okay, right. First, show that that is equal to 416, Lamai. $37. Question number 37. That is 2011 A-level question. So now you can understand that you need to first write down the expansion of 1 minus root 3 to the power of 6 lemma. So write down that expansion. Don't simplify it, okay? Just leave the answer with your notation. Identify the negative numbers. Then add it with the positive expansion number. So you can see this time again, there's 1 here. So we only have to worry about the last part. So that means that is easy, right? 6 pi lemma minus root 8 the power of 5. Finally, 6 cx lemma minus 3 root 3 lemma to the power of 6. So now identify the negative parts, lemma. What are the negative parts? This one is negative. This one is negative. And this one is negative. So we can just add these two now. So 1 plus root 3 to the power of 6. 1 minus root 3 to the power of 6. So 2 into 6c0. 6c2 minus root 3 square. 6c4 minus 3 to the root of 4. 6c6 minus 3 to the root of 6. So 2 into 1. 6c2 mean 6 into 5, 30, 30 by 2 mean 15. 15 into 3, that means 45. 6c4 means 6c2, 15, 15 into 9. 135. Here root 3 into 6, that means root 3 square, 3 into 3, 27. So, right. So 46 here. 162. So 8, 208. So that is equal to the 416. So just like that, we can get the answer. Right. Finished. Okay, fine. Now let's go to the last part today. Hence find the integer part of 1 plus root 3 to the power of 6 level. That means now we have proved that 1 plus root 3 to the power of 6 positive. 1 minus root 3 to the power of 6 this is equal to the 416. So 1 plus root 3 to the power of 6 that is equal to 416 minus 1 over root 3 to the power of 6 Now the thing is 416 minus. What can you tell about this one, Vitesh? 1 minus root 3 is that a negative number? So is that a decimal number or complete number? Root 3 mean what? 1.7 or something like that. So you can see this is some kind of a decimal number. So when you take the power of a decimal number, can that be a what? Number with integers put the power 6 can that be a number such that put a 2.3 point or something like that? What can you tell? That is the thing you need to know. When you take the power of any decimal number it's remain as a decimal number. What is the reason for that today? Imagine 0.3 mean today. This kind of a number, if you write it as a fraction today, it will be just like that. So when you take the power of numerator 3 to the power 6 to the denominator 10 to the power 6. You can see always denominator is greater than what? The numerator. So that means always this is what? Decimal number. That means 0 point something. It never take 1.2 points such that. Okay? So always 0 point some kind of a decimal number. So that means here 416 minus some kind of a decimal number. So when you subtract 0 point some kind of a decimal number from 416 what is the answer? 415 point some decimal number. So what is the integer part? Okay. That's it. So the integer part of 1 plus root 3 to the power part today 6. That is equal to the 415. That's it. 415. So keep in mind that thing, when you square when you take any power of a decimal number, there is always 0 point or something like that. Okay. So that is the first question type. Right? So that is the first question type. Here 415 point some decimals, okay? That means 415 is the integer part. Right. Okay, right. So that is the way to do if you got this kind of question today. So the last time it was asking about 2011. After that, it was never asked. But in the model papers today, you will meet these kind of questions. Okay? Right. Now, write down this subtopic again. After that, let's see what is our second question type. Okay? Right. Write down this subtopic today. General term of a binomial expansion. 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 Right. Now, Bude, just look at this one. Okay? Right. So this is the expansion of x plus y to the power of n lamai. Right. Now look at this one, Bude. Right. Now you can see here lamai. So this is the first term lamai. Normally, Bude, we denoted by T1, Bude. In all yours, I think you have used this one. Right? T1 is the first term lamai. So this one should be lamai. Second term, T2 lamai. And this one is Bude, third term. So like that, Bude, can you tell me what is this term lamai? No, not n. This is the first one, second one, third one. So this should be r plus 1. You can see the pattern here. If there's 0 lamai, here it is 1. If this is 1 Bude, it will be 2 lamai. If this is 2 lamai, this will be 3 lamai. So that means this should be equal to what Bude? Tr plus 1. And the last one is Bude. What is this term lamai? That is t n plus 1 Bude. Okay? So that means Bude, if the power is n lamai, how many terms in the expansion? N plus 1 ne? A plus b whole square. Power is 2 lamai. How many terms in the expansion? 3 lamai. Got it, Bude? Right. Next important thing is lamai. What is the equation? What is the general term lamai? Tr plus 1. Tr plus 1 is equal to what? NCR x n minus r yr. Okay? So this is the only formula you have to remember. Or in other words, Bude, this is the only formula we got in binomial expansion. There's only one. So what is that one, Bude? Tr plus 1 is equal to NCR x n minus r y r1. Got it, Bude? So this is the only formula we got here. Okay, right. Now, Bude, imagine you need to find out the third term lamai. If you want to find out the third term lamai, r is equal to what, Bude? 2 lamai. Okay. If you want to find the 10th term lamai, r is equal to 9 lamai. Got it, Bude? So that is the nature of this formula, Bude. They calculate TR plus 1 කියලා. Now, if you can remember the TR formula, you can remember the TR formula, but it will be ugly. NCR minus 1. Instead of R, Bude, you need to write down R minus 1. R minus 1, X, N R minus 1 plus 1, Y R minus 1. So this is ugly. Alright? So instead of this one, Bude, we remember this one. If you want to find the 10th term lamai, you can just apply 10 here. But here lamai, if you want to find the 10th term lamai, you need to apply 9 lamai. Okay? Right. Okay, let's write down this one. Okay? Right. Write down this one for the first. Then mark this T1, T2, T3 up to Tn plus 1. Don't write down these two, only the expansion. And name these as T1, T2, and T up to Tn plus 1. Right, but they finish. Right. After that, but they write down this sentence. Okay? After that, write down this sentence. There are n plus 1 terms in the expansion. There are n plus 1 terms in the expansion. So if the power is n lamai, there are n plus 1 terms in the expansion. So if the power is n lamai, there are n plus 1 terms in the expansion. Okay, next one put a general term TR plus 1. General term TR plus 1, comma, then put a write down this one and highlight this one. Again, put a write down TR plus 1 is equal NCR x to the power n minus y to the power r. Okay, right. Then we write down this sentence after that. Okay, again under this one, let's write down this sentence. If we want to find, if we want to find T5 or the fifth term, if we want to find T5, that means the fifth term within brackets today, fifth term, fifth term, we need to apply R is equal 4. We need to apply R is equal 4. Right. So keep in mind that okay? If you want to find the fifth term lamai, we need to apply R is equal 4 value lamai. Okay. Now let's see Pute. Now using this one Pute, without writing the whole expansion Pute, we can just find out a relevant term. Okay, let's consider this example Pute. Okay. Write down this question Pute after that. Write down this example question. Okay. Write this question Pute. Consider the expansion of, consider the binomial expansion of, consider the binomial expansion of 2 minus x to the power of 10. 2 minus x to the power of 10. You can see now there are 11 terms if you write down this expansion. Okay. Right. Find the ninth term. Find the 10th term today, not the 9th. Find the 10th term. Find the 10th term now. Now let's see how can we find the 10th term lamai without writing down the whole expansion today. Only the 10th term lamai. So this is the way to do this now. First of all, you need to write down the formula. So what is the formula? TR plus 1 in CR x n minus r, then y to the power r. Next, just listen to this one. Right? Then after that, you need to write down the relevant values here. So this time n is equal to 10 today. So 10 CR. What is the relevant x value this time today? That is just 2 lamai. So 2 lamai 10 minus r. What is the relevant y value lamai? Minus x. So minus x to the power of r lamai, just like that. Okay. So this is TR plus 1 today. We need what today? The 10th term lamai. Okay? So that means today we need T10. For that, we need to apply what today? Let's apply R is equal what? 9. Okay. I'm going to apply R is equal 9. Then we can get the 10th term number. Okay. So that means T9 plus 1. Look at the way I'm going to write out that. This is not T10 directly, but T9 plus 1. You need to apply that value here. Okay. Then 10C 9 to 10 minus 9 minus 6 to the power of 9. 10C 9 means 10C 1. That means just 10 lamai. Here 2 to the power 1 minus 6 to the power of 9. So the answer is 20 minus 20 x to the power 9. Got it, buddy? So just like that, without writing down the whole expression lamai, we can find out the exact term only lamai. That is the advantages we have in using this binomial theorem. Okay, we can find the exact term we need. Okay, write down the answer this one. So, but be careful only when you do this implication, be careful. You need to apply for the R. If you want the 10th term lamai, R is equal 9. So I will give you another question. Okay? Raining. Wow. Right, okay, Budhe? Fine. Write down the next question. Find the sixth term of x minus 1 to the power of 8. So what was the answer? Negative 56 x cube. This I can say. Negative 56 x cube. Okay. Wait, did you get the answer? Minus 56. This one. Got the answer? No. Right? Okay. Let's go. Do I want to solve this one? But I want to solve it. Did you get the answer? No. So TR plus 1. MCR xn minus r y to the power r. 8CR x to the power 8 minus r minus 1 to the power of r. Now we need a sixth term. So r is equal 5. 5 plus 1. 8C5 8 minus 5 minus 1 to the power of 5. T6 is equal 8C3 x cube minus. So 8C3 mean what they? So just like that we can get the answer. Right now, write down the next topic. Okay? Write down the next topic. Finding the midterm. Right? Finding the middle term or the midterm. Finding the midterm. Finding the midterm of an expansion. Finding the midterm of an expansion. Finding the midterm of an expansion. Okay. Okay, right. Now there's a small theory element. Now we know that today, if you consider a plus b whole square lamai, how many terms there in the expansion lamai? There are 3 terms today. If you consider a plus b cube lamai, how many terms there? How many terms lamai? Now there are 4 terms lamai. Right? So if the power is even, there are odd number of terms lamai. If the power is odd lamai, there are even number of terms lamai. Okay. Now the thing is lamai, in this expansion today, you can see there's only one midterm lamai. Okay. But here lamai, in this occasion, since there are even number of terms lamai, we consider that there are 2 midterms lamai. Okay. So the thing is lamai, if the power is even, there's only one midterm. If the power is odd lamai, there are 2 midterms lamai. Okay. So how can we find this midterm lamai? If the power is even, today, we can find the midterm today. Midterm is equal to n over 2 plus 1 term lamai. What to remember this one? Okay. If the power is odd lamai, odd power, we know there are 2 midterms lamai. There are 2 midterms. We can find these midterms today using n plus 1 over 2 and n plus 3 over 2 terms now. Okay, you have to remember this one. If the power is even lamai, you can find the midterm by n over 2 plus 1. That is the midterm lamai. Okay. If the power is odd lamai, there are 2 midterms. What are the 2 midterms? N plus 1 over 2 and n plus 3 by 2. Got it? We will write down this one. Right, write down this sentence. Right. If the power is even, if the power is even, if the power is even, there are odd number of terms. There are odd number of terms in the expansion. In the expansion. Odd number of terms in the expansion. Okay. We can find the midterm. We can find the midterm using n over 2 plus 1. Using n over 2 plus 1. Okay, right. Next sentence today. Next sentence. If the power is odd, if the power is odd, if the power is odd, there are even number of terms. There are even number of terms. There are even number of terms in the expansion. In the expansion. In the expansion. In this case, we can find 2 midterms. We can find 2 midterms. We can find 2 midterms using n plus 1 over 2 and n plus 3 over 2. N plus 3 over 2. Again, this is not that important. Question. So let's do one more question from this question type. Okay, right. Write down this question today. Write down this question today. Find the midterm of mid term of 2x minus 1 to the power of 5. Not the power of 4, it's a power of 4 lamai. 2x minus 1 to the power of 4 lamai, not 6. Sorry. Right. Because now there are odd number of terms lamai in the expansion, we can find only the midterm lamai. So what is the term lamai? So midterm is equal to n over 2 plus 1. So 4 over 2 plus 1. That means 2 plus 1 today. We need to find the third term. We need to find out the third term. That means we need T3 lamma. We need to find out the T3. Right. Now, before you find the T3 lamma, I write down the formula first. So what is the formula? TR plus 1, NCR, N minus R, YR. So N means 4, 4CR, 2x to the power of 4 minus R, Y mean minus 1 to the power of R. Now obtain T3 lamai. Let's apply R is equal to. So T2 plus 1, 4C2, 2x squared minus 1 squared. So T3 is equal, 4C2 means 4 into 3, 12, 12 by 2, 6. 4x squared, positive 1. That means 24 x squared. So just like that, we can find the midterm of this expression. Okay. Right, Bude? Right. Right, Bude? Right. Right to the next one, Bude. Finding the independent term of x. Finding the independent term of x. Finding the independent term of x, Lama. Finding the independent term of x. In other words, we say that this is the constant. Constant. Finding the constant within brackets. Finding the constant. Finding the constant. Okay. Now let's see how can we find the independent term of a binomial expansion. Okay. Look at this example, Bude. Right. Write down this question, Bude. Find the independent term of find the independent term of x squared minus 1 over x to the power of 9. Find the independent term of x squared minus 1 over x to the power of 9. Right? That means we need to find out the term lamai where x does not exist lamai. That means what? The constant. Right? So x does not exist mean lamai. What is the power of x? C. So that means we need to find the term lamai where x to the power is what? 0 lamai. Let's see how can we do this now. First of all, as usual, you have to write down the formula. NCR x n minus r yr just like that. Right? Let's apply the values lamai. N mean 9. 9CR. X mean x squared 9 minus r. Y mean minus 1 over x to the power of r. Now look very carefully. We need to do the simplification here. So how can we do the simplification here? They are indices. So we can multiply by this 1 9 minus 4 with this 2. So 18 minus 2 4 2r. Here minus 1 to the power of r, x to the power r. Okay. Now 9CR, when you divide this term with this term, what is the answer? X to the power. When you divide of the same base numbers, put the indices will be subtracted. So 18 minus 3r, minus 1 to the power of r. Okay. So we can come up to this point. Now we need to think about what is the relevant r value when x to the power 0. Okay. So here I'm going to consider let's consider x to the power 0 that is equal to x to the power 18 minus 3r. If the bases are equal, indices are equal number. So that means 0 is equal 18 minus 12. So what is the relevant R value number? That is 6. So that means when R is equal 6, we can get the independent term lamai, independent term of X, or the constant. So when R is equal 6 lamai, what is the term? T7. 7th is the term lamai, the constant term. Got it, Bude? So here I'm going to write down Bude. When, that means Bude, T7 term is the constant. Is the constant. So I'm going to find out that term lamai. So I'm going to apply when R is equal 6 for this one. So that means T6 plus 1 is equal 9C6 x 18 minus 3 into 6 lamai and minus 1 to the power. So always be careful, we are going to apply the value for TR plus 1, not TR. Apply T7 we apply R is equal 6. Okay. So here it will be T7. 9C6 pin 9C3. Yeah, you can see x to the power 0, we can just forget about that one. Minus 1 to the power of what? 6. That means that will be positive 1. So that is equal what? Just 9C3. 9C3 means 9 into 8 into 7 or 1 into 2 into 3. So 3 into 3, 2 into 4. So that means 12 into 7 means 84. 84 is our constant. So like that, we can find out the constant term. So that is the most frequent question type for the A-levels. Always they ask to find the independent term now. So that's it today. We only need to discuss about one more thing now, that means the sum of the odd coefficients and sum of the even coefficients today. Again, I discuss currently. There was another part today before 2019, but after 2019 today, that part has been removed. That was the biggest part of this lesson. Finding the largest term, that we remove that part. 2009. Okay, right. Now for this question again, I'm going to ask another question. Write down this question as well for this question. Fine. Find the coefficient of x cube term. Find the coefficient of x cube term. Find the coefficient of x cube term. Right. That means when you write down the expansion, there will be a x cube term. I need to write down the coefficient of x cube term. So this is the way to do this again. Again, Pude, you need to come up to this point and then end road, right? After that, Pude, I'm going to find out the relevant R value when we get this x cube value. Okay, nice. So here, Pude, I'm going to consider, let's consider x cube is equal to x to the power what, Pude? 18 minus 3r. So 3 is equal 18 minus 3r, Pude. That means 3r is equal 15. R is equal, Pude, just 5 lamai. Okay. R is equal 5 means what is the relevant term lamai? 6 term lamai. So I'm going to write down, Pude, when R is equal 5, Pude, T 5 plus 1, Pude. Again apply here 9C5. Then x to the power 18 minus 3 into 5 lamai. Minus 1 to the power of 5. So T6 is equal 9C4 x cube negative lamai. So that means minus 9C4 x cube lamai. So this is the coefficient of x cube lamai. We need to find out minus 9C4 lamai. So that means minus 9 into 8 into 7 into 6 lamai over 1 into 2 into 3 into 4 lamai. So 4 into 2, 2 and 2 will cancel out, 3 into 2. So 9 into 7 mean what, today? 63. 63 into 2 mean 126 lamai. So this is the coefficient of x cube lamai. Right. So here we can write down the coefficient of x cube is minus 1 to 6 lamai. That is the coefficient of. So just like that, today we can find out the relevant coefficient of a given term. Okay, write down this one. Right, okay. Write down one more question for this question again. Right, so write down this question again, okay? Right, write down this question today. Show that there does not exist x to the power 4 term in the expansion. So that there does not exist x to the power 4 term in the expansion. Right. Now how can we show that today? There does not exist x to the power 4 term in this binomial expansion lamai. Again today we are going to equate these two lamai. Let's consider x to the power 4 is equal x to the power 18 minus 3r lamai. That means today 4 is equal 18 minus 3r. So 3r is equal 14. R is equal 14 by 3 lamai. But we know that today R should be what? It must be an integer lamai. It can't be a fraction. It's integer. So here lamai we got a fraction. So we can say that what put it? R must be an integer lamai since in the expansion there does not exist any x to the power 4 term lamai. That's it. Okay. Right. Let's write out that one today. Hence R is an integer. We can say that today. In the expansion does not exist x to the power 4 term. In the expansion today there does not exist x to the power 4 term.